Welcome to this session. In this session, we again look at the independent risk factor low density lipoprotein cholesterol level with respect to the outcome CHD. But in this case, we want to make more sense about the odds ratio. Remember the odds ratio before? For 1 milligram per deciliter increase, the odds changed by the factor of 1.015. That was the odds ratio. But what does that actually mean? We want to make sense of continuous units. So it's hard sometimes for continuous variables. So let's have a look on the LDL scale itself. Here we see that everything a level below 200 is considered as desirable. Then we have an interval of 40 units from 200 to 239. It's borderline high, and everything above the threshold 240 milligram per deciliter is considered as a high LDL cholesterol level. So we could ask, what is the odds ratio for a 40 unit increase in LDL cholesterol level? So what does an increase of 40 milligram per deciliter mean? So that's what we can answer with the logistic regression. To do so, we just have to transform the LDL variable. So let's do this. So this is our data set again. We see here the independent variable LDL with 1 unit increase, meaning 1 additional milligram per deciliter. Now we want to figure out what the odds ratio is for a 40 milligram deciliter increase. So what we have to do is to create a new variable that divides this variable by 40. Then each full step on the scale means an increase of 40 milligram per deciliter. So let's compute this variable. We click on transform, compute variable, and then we name the target value, the target variable, which is LDL, milligram per deciliter underscore 40 per unit. Then we select the LDL and drag and drop it into this window and divide it by 40. So each increment means an additional 40 milligram per deciliter. Okay, we got that. Then I click OK and I generate a new variable. Here the result viewer confirms the computation. And when I go back in the data viewer, I see here that a new variable is created. So when I look at this variable 2 and this variable 1, this actually means an increase. So this is 1.03 and 2. On this scale, this means an additional 40 milligrams per deciliter. That's what we wanted. Now I can just create my regression model, analyze regression, binary logistic. My CHD variable stays. So that's the outcome variable we want to investigate. And now I can click this LDL milligram per deciliter for 40 units as the independent variable, and I click OK. And now here I see the exponentiated beta. That's the odds ratio. And now we see that the odds ratio for a 40 milligram per deciliter increase of cholesterol means 1.85 or 1.8. This means an increase of 40 milligram per deciliter of LDL blood concentration means that the odds of having CHD increases by the factor of 1.84, or we can roughly say the odds double. So a patient with a level of 200 and a patient with a level of 240, and then the second patient has a risk that is twice as high as the first person. As a note, this odds ratio is valid for each step on the scale. So when someone increases from 40 milligram per deciliter to 80, then this would mean also a doubling in the odds, or more precise, the odds change by the factor of 1.8, the odds ratio we just calculated.